Hello all, welcome to the video lecture series for the subject operating system. Now I am going to explain you all about a classical synchronization procedure, that is reader-writer problem. How does this particular solution will make the classical synchronization problem access? Right. Now you can check that we have three different aspects here. Number one is mutex, number two is WRT, that is writing procedure, and here we have read count. These are all the three different variables we have. Basically, this classical problem of synchronization, where this reader and writer problem has been arised, it is actually a database is to be shared among several concurrent process, right? Different concurrent process has been shared with one particular database. Some of this process may want only to read the database, or else it can other may want to update, or else to read and write at the same time with one particular database. So there will be a race condition is applied. How does this problem resolves? So here comes the solution, reader writer problem. So I have a pseudocode definition for this two procedures here. One is process, for example, process one is trying to perform a read process, or else it is trying to perform a write process. Let me tell you how does this procedure executes. Now here there is a write procedure with only two conditions, that is wait. You all know that wait is to acquire, signal is to release. It's a semaphore condition. So wait will write the process, that is this particular function will perform write, right? This particular condition will perform leaving, that means it is to acquire, it is to leave. Well, this true, it will keep on executes, right? So let's get into the read process now. Read have several other extra conditions to be done, right? Say for example, first thing is wait mutex, that means it is to acquire the lock, right? This is for the wait. And once it is acquired, the lock is acquired, that means the condition is true and I mean the condition is false, that means nobody inside in critical section. I'm going to enter. Who is going to enter now? Read process is going to enter. That is the one procedure process one is doing. Process one is reading. Once the critical section is free, I'm getting enter by using this wait mutex, that is acquire the lock. Once this read process one is getting enter, read count has been incremented. Why this read count has been incremented? It shows by 1. Say for example, read count is equal to 1 now after this increment. That means it indicates how many readers are inside. That's the procedure, right? So let me get into the next line. If read count, the read count is double equal to 1. That means here this procedure, that is read count is getting inside, is equal to 1. So reader is already inside. So it is not allow, it won't allow any writer to come inside if this particular read count is, read count is 1. That is already one reader process is already inside the critical section. So reader and writer cannot share the same database. That is the condition here. So the wait WRT has been set. So this is the procedure. It makes the write condition to wait, right? It will keep on wait until this read count is 0. Now the read count is 1. So no write procedure is adopted over here, right? Now the signal mutex. Now what this particular thing will do is, two reader can take the database, can share the database at a time. That is a procedure. So I am sending a signal to other readers who can get enter. If for example, some other reader is waiting outside for only performing the read operation can get enter. This is the signal which is given for that mutual exclusion inside the signal, right? It is for releasing and it is for making the other readers to come inside, showing the way, right? So in the next line, you can check what is this current reader is performing. See here, for example, current reader want to go outside of this critical section. So wait mutex, it is passing this wait mutex condition. Now mutual exclusion is releasing the lock. So it has to do this condition. Read count is equal to, that is read count is minus. So initially read count is 1 because I am inside. Now the read count is Initially the read count is 1. So 1 minus minus, the answer is 0. Now the condition is here. When I'm going outside, I need to make that read condition into again the same position. Read count is now 0. If read count is double equal to 0, so now there is no reader inside this critical section. Now I'm sending a signal to WRT, that is, I am asking the writer to come in. That's a point. So now after this signaling has been done, that is no read count, that is nobody inside this critical section, only then the writer can come inside. So the signal has been passed, that is this signal is to leave. Whichever process is inside, process 1 is reading and process 2 is also reading. The signal has been passed and both this reader has been getting outside this critical section. The while 1, that is true always. The same condition will be keep on working when the condition while loop is true. So the ideology of this particular reader writer problem is one line. If two reader is inside, or else if one reader is inside the critical section, no writer can get in. Simultaneously, two reader can share a database, but a reader and writer cannot share a database. So the logic here it is, if reader is inside, one more reader can be allowed. If reader is inside, writer cannot be allowed. If the read count is 0, that is no reader is inside the critical section, the writer can come inside. At a time, two writer cannot go inside. So these are all the procedures which is made in this particular read write problem technique. So obviously, if two readers access the shared database simultaneously, no adverse will affect the result. That is the procedure here. Thank you.